been a joy to watch you as you have grown the company and scaled the company. I remember in Alameda, you had the small office and the testing center for the rockets from a former naval base, and then continued to take over the real estate, and now you have a massive rocket factory there. Tell us a little bit about your journey and why you started Astra.
Well, it turned out back when we first met, there were a number of different companies that were building small satellites. And the idea that you could take the technology in a cell phone, the sensors, the radios, the cameras, the memory, and you could put it in space was thought to be impossible. That the satellite wouldn't last very long, the radiation would destroy the satellite. But a few pioneering companies started up and they launched effectively smartphones into space.
Right.
And they worked. And then they started to build on that and iterate. And at the time, they were really struggling because rockets are big. They're giant machines, if you've seen some of the rockets that are being built these days. And they're designed really to build people and put people in space and create multi-planetary species for humanity, not put little cell phone-sized satellites in an exact orbit. And so there were so many of these companies starting up. The real genesis of the idea was if we could democratize access to space, if we could have more launches going to more places, instead of just one rocket maybe every couple of months going to a place, we would catalyze this new industry and we would accelerate the development of all these companies.
Amazing, and you're basically talking, I remember you said this to me and it reminded me of Travis telling me that Uber was not just about taxis, it was a replacement of car ownership. And what you said to me is Astra is not just another rocket company, we're going to be the FedEx of space. We're going to do daily launches and democratize access to space. One of the areas that you've touched on as a vision from early on was this idea of an open space internet.
Yep.
And bringing that kind of connectivity to the world. And everyone has seen Starlink, but that's more of a closed network versus your vision of an open network. Can you jump into that a little bit, given what's happening in Ukraine and the use of Starlink?
Well, if you think about traditional infrastructure, if you put fiber in the ground, you've put it in the ground in your country. If you put a big billion-dollar communication satellite in space above your country, it's beaming right down to your country. But these new satellites are traveling in low Earth orbit, which means they're traversing your country in maybe 15 minutes, maybe 10 minutes. And so they spend most of their time over other countries. And the constellations that are being built by companies like SpaceX and Amazon are global constellations.
Right.
And so the big idea that we have is if emerging economies could build smaller constellations that can work together to form a constellation of constellations, much like the internet is a network of networks.
Right.
We can have a global constellation of tens of thousands of satellites providing both reliable global coverage, but also if your country wants to have the security of only routing traffic over your satellites, you can have enough of them to accomplish that use case. And so we see the internet moving into space, and then the sensors that are in space being able to bring data back across that network, maybe even have compute and storage in space, where we can just really solve all sorts of problems.
Let me just double click on this. Just from an engineering mind, if you could simplify it for everyone in terms of that technical stack of imagine an AWS in space, that kind of ad hoc networking, mesh network. Could you explain to everyone in the audience how that technically works?
Yep. Well, think about a satellite. Maybe the satellite takes an image of something. Well, the satellite typically has to wait until it's over a ground station to get the data back to the cloud or to wherever it's being processed. Imagine if you could do the processing in space and figure out what you're trying to figure out. Is there water here? Is there a pipeline that's been broken there? Whatever the use case is.
An earthquake in Turkey.
An earthquake. And what you want is you want that instantaneous. Like you want to know that that's happening when it's happening, not hours or days later.
Right.
And so what we're seeing is with more satellites and more sensors in space, the need for more real-time processing and AI being able to be leveraged so that you're not able to look at every single pixel. Humans are not looking at a picture of the entire planet every day. You need to rely on computer vision and AI to help make sense of it all and call out the things that are important.
So the actual satellites are communicating with each other in space in a mesh network with lasers,
Yep.
laser beams actually going back and forth between them.
Yep.
So that's technically how it works.
Yeah, it's just like if you have the internet, you have to lay a big fiber connecting this city and that city, and then in the city you have a router,
Yeah.
and that's a physical cable. Think in space, you can just point a laser between the two satellites,
Right.
and the network is actually faster because light travels faster through free space than it does through a fiber optic cable. And then you have thousands of satellites that are all connecting to each other just by pointing the lasers at each other.